Hello and welcome to this ParaView tutorial. My name is Alberto Armando and today we are gonna cover the basics of ParaView. In this presentation we will do an introduction, we will talk about the files and data that ParaView uses, and some of the software basics. So now we can start saying that ParaView is an open source, scalable, multiple visualization application to convert scientific data to scientific visualization. It supports distributed computation models and it can handle large data sets. Is it open source, flexible, and it has an intuitive user interface. It's modular and this architecture is based on open source standards, so it allows parallel visualization applications. Regarding the supported data files, here we can see that it supports lots of data files, but mainly the most common ones are the first two, the ParaView data.pvd and the VTK files, which are commonly used for other applications as well. We have some examples like .btp, .btu, BTI, BTS, and BTR. Regarding the VTK files that we are using, they are files based on XML, so they contain data within some tags that we will see later. And basically they contain the grid and the data of our model. There are different types of grids. For example, here we can see some of the main VTK grids, from uniform rectilinear, non-uniform rectilinear, curvilinear, polygonal, unstructured grids, or even more complex grids like multi-block, hierarchical, adaptive, mesh refinement, etc. Then another thing is the VTK cell types. And here we have two different types. The first one is the linear, and is it characterized because the edges are linear and first order. And on the other hand, the non-linear type has non-linear edges, specifically quadratic edges. And we have different vertex, lines, cells, and different 3D cells like hexaedrons or even wedges or pyramids. Here, depending on our application, we will use one or another one. We can always choose the most convenient cell. Here we can see an example of a 2D case, which is a 2D VTK UnstructuredGrid.btu. And on the left hand side, we can see the grid. It's a simple grid with 8 points or nodes in red and 6 cells, triangular cells, in blue. Then here in the center we can see an example of a BTU file, which starts with the headers saying that it's an unstructured grid, which has a piece with this number of points and this number of cells. Then within these tags, points tags, we specify the coordinates x, y, z of each node or point. Then regarding the cells, we have to include the connectivity of these cells, which means which points form the specific cell. For example, cell 0 is formed by point 0, 1, and 3. So this is information that we have to provide. Then we have to specify the offsets and the types of cells. In this case is triangular. The next tags are called point data, which contain the data from each node or point. For example, here we have pressure and some velocity. It can handle scalars, vectors, etc. We will see it later. And then finally, the cell data. This data is centered on each cell, and it can contain any kind of information like scalars, vectors, etc. as well. Finally, the VTK file is closed, closing the tags, piece, UnstructuredGrid, and VTK file. This example could be loaded in ParaView and represented. Then, before opening ParaView and starting using it, it's important to understand the data. First of all, we have the mesh. The mesh is the geometry of our model, and it has its nodes with XYZ and the cell connectivity. For example, cell 1 is formed using nodes 1, 2, 3, and 4. And on the other hand, we have the data or the attributes. And this data can be specified on nodes or on cells. In the first case, here on the top, we can see that each node has a point and a specific data. And then in ParaView, is it possible to interpolate with this gradient of color and to obtain this visualization? On the other hand, if the data is cell-centered, in the center of the cell, the values are on the center, and it's not possible to do this color interpolation. We will have a color for each cell. Nevertheless, we have this option in ParaView to transform from node data to cell-centered data, and from cell-centered data to node data. On the other hand, the types of data that we can include are scalars, which are single data values, 3D vectors in a 3-dimensional space, 3-dimensional normals with a norm of 1, then more complex data like texture coordinates or tensors or field arrays. Now we can start with ParaView, and the first step would be to install it. And in order to do it, we go to its page in the download section. We will find this tag to select the version. We can select the last one, and then we have this option to select our operating system. Is it available for Windows, Linux, and Mac? We can download this and install it in our operating system. Note that for Linux users, we can do it easy with the sudo apt install ParaView. Okay, once we are installed ParaView in our computer, we can open it, and we will first see the user interface. And of course, we won't see this toroid here, but we will see the menu bar on the top, which includes the typical file, edit, view, etc. Then we will have some useful toolbars here in the middle that we will cover later. Then a very important area, which is the pipeline browser. Here we will see and we will track what we do with our data and what kind of filters and operations we do with this data. Then we have the properties panel. Here we can change some properties of the imported data or the filters that we add to this data, etc. We also have an advanced menu to change advanced properties. And finally, the main layout here, where we will see our visualizations. These toolbars sometimes are not active. they are not enabled. So we can go to View, Toolbars, and we can activate them all if necessary, if we are missing some. First of all, we have to understand the sources of data of ParaView. ParaView has two different types of sources. It has some built-in ParaView sources where we can find within the sources menu here on the top. And for example, we can get some geometric shapes like cubes, spheres, etc., or even data. And then we have the data that we import, which is mainly what we are gonna use. Then in order to import data, we will go to this icon here, which is import, and we will select our folder and we will take our BTU file, click OK, and then we will apply. Now we are gonna do an example of importing data, opening ParaView in my computer and showing you how to do it. In my case, I am in an Ubuntu operating system, so I will open the terminal and write ParaView, and it will start the software. I will put it here in order to view it. So now we are going to import the data. We can do File Open or directly click here in this open icon. Now we go to our folder and we will select our BTU file. Okay, now we have here the properties and information tabs. Here we can select in the properties what data we want to include, and then we click apply. Here we can see the geometry and the grid. Okay, now we're gonna talk about the information tab. If we open it, here we can see some properties like the file name, the path, some statistics, the data that we have, the range of this data, etc. And we come back to the properties. And here in the properties, we have mainly three tabs. We have properties, display, and view. In the first one, the properties, we can select the data that we want. For example, imagine we don't want the temperature anymore. We enable this and we select apply. We always have to do apply. If we want the temperature again, select and apply. The second one is the display. In the display, we have the representation, the coloring, and the styling and lighting. The geometry representation, which we can find it here, allows us to visualize the grid with different strategies. For example, we can see the nodes as points, the wireframe. Here we can see the cells as a surface with edges, or even the volume. For example, in our case, if we can try the points, you can visualize this. There are two layers, spherical, and here we can visualize it. For example, the wireframe. Here we can see the three-dimensional hexagonal cells. Or we can come back to the surface with edges, and the volume has to have a certain variable to color it. Now let's come back to the surface representation and we select, now we will talk about the coloring. Here we will, instead of solid color, we can plot the temperature, for example, which is a scalar. And as the temperature is a value which is a cell-centered attribute, each cell will have its own color. So the resolution is not really good here, but it shows the example. Now, in this case, the next section talks about the transfer function editor. What does this mean? This means that if we want to change this color scale, we can click here on Edit and we will find this tab. Here we can map our data according to different colors and we can add points and change all these scale. On the other hand, we have some presets here in the heart icon preset, and we can choose all these colors. For example, another typical one, the black body radiation scale. We click apply and close. We can see it with another scale. Let's change it again to the cool to warm, which is the standard. And that's it. Now let's talk about some useful toolbars. Here we have the active variable controls, which is this one. And here we have the toggle color legend visibility. We can include the legend or no. Here we have the edit color map, which is the same as we saw. Then we have some tools like to rescale the data range to the custom data range. If we have time steps, to rescale the scale to the whole time, and also to rescale the to visible data range. On the other hand, we have the representation toolbar. Here we can represent temperature, or for example, the magnitude of the magnetic field. We do this, it represents a cell-centered. This is cell-centered and this is node in the node data. In this case, here we have the magnetic field magnitude. Then also we have these tools to manipulate the camera. We can move it, center it. For example, if we lose our visualization, we click on this and we center again. We can zoom in a specific area. We can view to specific directions, X, minus X, Y, etc. We can rotate the viewing. Also, we can show and not show the axis. We can rotate choosing a specific center, etc. Okay, and now we are going to talk about an important topic in ParaView, which is the visualization pipelines. So how does ParaView work from the data to rendering and getting this image? So what it does is it takes some sources, for example, in this case, 2 sources, and creates data objects. Then it applies some filters. Filters can be, for example, the visualization of a vector field or a contour plot or slice, etc. And then you can apply as many filters as you need. And finally, the engine renders your data and you can visualize it. Then I wanted to mention the sources, filters, and mappers. Sources has no input, for example, a geometrical source or a data source, and has one output. Then filters can have multiple inputs and multiple outputs, and there are different types of filters. Filters that give a single output and using a single input. Filters with different inputs and multiple fan out data, and filters with multiple output data. And finally, the mappers has some inputs and no outputs. For example, it's the last step in the pipeline browser, and this is done automatically by ParaView. The most common filters are the calculator, contour, clip, slice, etc. For example, calculator, you can get new variables using some of your data. Contour, you can plot isosurfaces of certain data. Clips, you can see the inside of your volume, slices, etc. In our case, two of the most important ones is glyph to represent vector fields, and stream tracer, which will allow us to visualize the streamlines of this field. We can find all these filters in the filters menu here on the top of ParaView, and here you can have all the filters, but the most common one are these ones. Here you can see that they are not available because I have to select the data from which I want to apply them. Sorry. And now the ones that are available are highlighted, and the ones that cannot be used are in gray. Other filters, for example, for data analysis include the plot of variables over time or over a specific line, etc. They can be found in the filters data analysis menu. Then the pipeline browser. In this case, for example, in this example, we have this file, which is the original data, and then we apply two filters, a contour and an extract surface filter. And from this extract surface, we add also a clip. Then in the pipeline browser, we will see it like this. The original data file has some branches. The first branch is from the contour, and the second branch is the extract surface. And the extract surface has another branch, which is clip 1. We can toggle these eye icons to make them visible or not. If it's gray, it's not visible. Okay, now we are gonna try some filters in our case, and we will see how it works. As an example, we will add, for example, clip filter. We have to select the source file here. Then we can use the toolbar, or if we need another filter, we go to filters. In this case, we're gonna go to common, and we are gonna do the clip. At this point, we will see that the properties has changed. and we will have this apply, reset, and delete option, and then properties, display, and view. So if we open the properties, this will depend on each filter. In the clip, they will allow us to select if we want to clip with a plane, with a box, with a sphere, etc. In this case, for example, a plane is okay. And we can see here the preview of this clip. It's gonna split our sphere into two. We can select some parameters of the filter, etc. Then once we are happy with these properties, we have to click apply. And now we can see the clip. Now it will allow us to change the representation again. If we want to change it to wireframe, for example. And also we can change the coloring according to different variables. We can use temperature, or even if we have a vector field, we can see the magnitude or each component. Etc. And this is an example of a clip. So, and this is the view, the display, sorry, the display area. And finally, we have the view and render, which is allow us to see some axes, the cell, the center, etc. Okay, now another useful thing is, for example, if we want to change this plane regularly, instead of changing this, imagine I change this, but the filter is not applied. I have to manually click apply. There is an option to do an auto apply, which is here on the top. Apply changes to parameters automatically. If we click here, we don't have to click to this apply. Then we can change the filter parameters and it will be applied automatically. We can play with this to see some data. And that's it. Another useful thing is the multi-view option that ParaViews allows. Here we can have different options. For example, we can add more views horizontally, vertically, or we can go back filling the entire view or deleting a view. For example, here I can apply an horizontally, well, a vertically view, and it will ask us what kind of view we want. We can do different charts, histograms, etc. But in this case, let's go for the render view, standard render view. And here, as you see, this area is highlighted in blue, and we can enable different things. In this case, we can compare different angles or different even different values, like we can see temperature and the magnetic field at the same time. Another useful thing is the annotations, where we can find in sources. Let's close this. Sources, annotations, and here we can go to text, for example, if we want to add some title, or For example, if we have an animation, we can go to sources, annotations, annotate time, and sorry, let me remove this. And here, if we animate this, we will see the time. Okay, now we are going to talk about animations, and let me do this like this. Okay, so the file to create animations is the ParaView data file .pvd, and it is also a VTK file using XML tags. And here we can see the header of the file, which is a collection of different BTUs, and this collection goes from time step 0 to time step 24, and their corresponding files are BTU files. So we will have in our folder from 25 BTU files and one PVD file. Then, in order to do animations, we will import the PVD file. Let me do it and show it to you. So let's remove this completely and we will start again. In this case, we will open the animation.pvd. Okay, here we have again the representation, etc. And now let's talk about the animation toolbars. So the easiest way to see the animation is using this toolbar, the BCR controls and current time controls. This allows us to play the animation, to go to the first frame, to the previous frame, to the next frame, last frame, and do a loop of the animation. Here we will see the current time and the current step. Here we can see, in our case, it is here, and now it's in the time 24. We can put it on at the beginning, 0, and we will have to select a variable, a color, and the scale. So we will go to coloring. We can see, for example, the magnetic field, and at this time, if we want, there is an option to rescale to range over all time steps. This allows us to rescale this scale because, for example, in the first time steps, the magnitude is very low, but then in the last ones, the magnitude is high. It scales this range, having into account all the time steps. We can click here to do it. Rescale to data range over all time steps. And you can click here. Okay, once we have done this, we can try to play the animation. And we see it. This option, the loop option, allows us to continuously animate the data. We can stop now. Okay. And this is the basics. And if we want some more options, we can go to View and Animation View. View, Animation View. In this case, we will have this menu where we can see this selection option called Mode. And there are 3 modes. Mode 1, Sequence, Mode 2, Real Time, and Mode 3, Snap to Time Steps. In the first mode, Mode Sequence, the ParaView allows us to select the starting time, the ending time, and the number of frames that we want to apply. For example, here we have 50. Even though we have 24 time steps, ParaView will interpolate 50 frames. We can animate this case, and we have the result. Okay, and the second mode is the real time. It's the same. It allows us to put a starting time, ending time, but in this case, we specify the duration in seconds. We want the animation to last 5 seconds. We play, and now it's slower. And finally, we have the last mode, snap to time steps. And in this case, it simply, as it says, snaps to the time steps that we provide. In this case, we provide 25 time steps. So it will take them as each frame. Each time step is a frame. Okay. We can select the type of animation that it's more convenient for us. Another useful thing is the time inspector, where we can find it in View, Time Inspector, View, Time Inspector. Here is a bit hidden, but we have to click here. And now we have the same options as in the toolbar, plus we can see the frames, and also if we have multiple animations, we will see them all here to have a better, proper control. Then another interesting tool that ParaView gives us is the smoothing of an animation. And we can do it going to Filters, Temporal, and Temporal Interpolate. Let's see how it goes. Let me deactivate the auto apply. And now I go to Animation, Filters, Temporal, Temporal Interpolator. In this case, we click Apply, and we have interpolated over the time. Now, how can we do this? We can go to the animation view, and for example, to real time, and now we will see that we have a duration of 5 seconds, which was the same, but it will be smoother. For example, if we remove the filter, let's compare it. We play now. Let me do the same. 5 seconds. It's not as smooth as before. Okay. Okay, now how can we save this animation or screenshots? First of all, if we want a screenshot, we go to File, Save a Screenshot. File, Save a Screenshot. We can save it here, okay. Or desktop. We can change the image resolution, the compression level, etc. And we click OK, and that's it. And on the other hand, if we want to save the animation, File, Save Animation, Save Animation, Animation, we change the resolution as well, etc. We can change the transparent background or different backgrounds, and we click OK. Save animation progress, and that's it. Well, and for now, this is all the content that I prepared for this tutorial. And if you have some doubts or you want more information, you can check the help menu here. You can have some useful help and tutorials. Check the user guide, check the tutorials of the ParaView website and its website. And if you have any specific problem, you can even email them to this email. And that's it. That's all that I have. I hope it has been helpful, and thank you very much for attending this video. Bye bye.